or you can call me Ozgur. My name is Ozgur Ozturk. I currently work at Philips since January as a data scientist. I worked at Career Builder before here again as a data scientist. I had been working mostly on productionizing, creating APIs, serving the data models, and working together with my data scientist friends. And today we will do a brief intro to machine learning with scikit-learn. So this is for people who are not really experienced. It is an introductory class. But we will have other sessions in the future. You can follow us at meetup.com/datasciencepros. And we will have other events posted there. And actually, we will have an extended version of today's EDA by Kulsum and machine learning by me on November 28th as part of Data Science Connect Tech. And the organizer graciously gave us a $50 discount code for you. So if you enter ATL Code Camp 50, these will be your prices for the conference and for the conference plus workshop. They don't give the option of only workshop. This is from the Data Science Contact website. We will be again doing the intro to data science using Jupyter. But there we won't be using Docker images. We will expand this workshop, add more materials, and host it on cloud. So you'll be able to connect to a cloud service where Jupyter is already installed and run all these codes step by step without having the difficulties you had with Docker, hopefully. By the way, by coincidence, today I saw that today's free book on pack publishing is Docker on Windows. So maybe it might help with some of the problems you are facing on Windows, I don't know. But it looks like it is more about installing Windows applications into Docker. But I'm guessing also it might have something about running Docker on Windows as well. So you can check it. Every day they offer one free book. So today I'm working with the housing prices data that Kulsum already pre-processed for me. And we will do some machine learning. And next slide. So you're already familiar with machine learning, I assume, since you are here. But still, you might not be realizing how prevalent it is now. How much different application domains. So you have applications in medicine, computational biology, like diagnostic expert systems, tumor detection, drug discovery, DNA sequencing. You have, of course, systems that play games like chess, Go, poker, or Flappy Bird. You train a machine to be able to learn what to do to beat in Flappy Bird. Computational finance, credit scoring, algorithmic trading. Actually, this is a very hot topic about the impacts. Also, because of algorithmic trading, frequent trading is so common now. It makes the markets more unstable. When the trend is going down, all the machines start to sell that stuff because it sees that it's going down, and then it goes down faster than it used to previously, etc. So it encourages the market to have more crashes, etc. And then we have applications of marketing, ad targeting, lead prediction. And recently, it has been more applied to voice recognition and text-to-speech as well. So now, both Google and Bing, Microsoft has voice models using machine learning that are trained by machine learning, and they have a very good quality, natural sounding text-to-speech systems. Of course, there's applications to text data, natural language processing, like classification of or clustering of articles, resumes, human profiles. Those kinds of things I was doing at Career Builder, for example. You can apply it to spam detection, machine translation, and we have recommender systems like what product to buy, next movie to watch, or next date in matchmaking systems. And there is lots of different types of machine learning. One type is unsupervised learning. Basically, it is some type of clustering. And there is supervised learning, where we have certain labels already given to the data. So in our case, we already have the sales value in our data. That's our target, that we want to train our model to predict the sales value. And we have past examples of all those features for the house and the sales value of those houses. And similarly, for example, Google trained their spam detection algorithm based on previously labeled emails that were labeled as spam, for example. And in supervised learning, you have again two types. One is regression, one is classification. Classification is for discrete values. So you assign it to certain classes, like spam, not spam. And regression is for when you want to assign a numeric value. You want to predict a continuous value, like the housing price prediction. That is the example I will be doing today. We will do a regression to predict the house price value. So, a formal definition, a process, so machine learning is a process by which a computer learns how to be successful at a certain task without being explicitly programmed to do so. So in the past, for example, you would hard code certain methods to assign, to diagnose, for example, based on expert knowledge from expert people. You know, subject matter experts would tell a programmer, okay, if these are the symptoms, then this is the diagnosis. So they would have like a branching, maybe structure that is coded, hard coded. But now, with machine learning, you just feed the data, and then the estimator comes up with a model that describes the matching from the input to the output. So you don't explicitly program, you just give the data, and the program learns from the data. Algorithms use the definition of success to fit a model that transforms the input into an output. It chooses the best features to predict the output, and then finds best parameters, thresholds, to create the function, the model, that predicts the value closest to the actual output in given training examples. So, for example, in the example I will be giving, we will be doing a linear fitting. And we will see the example of how the machine learning finds the parameters of that linear model. That is what we call fitting. And then this model is used to predict the output for new cases. And there can be, under these categories, there can be lots of different algorithms. So for example, for regression, you might have linear regression, support vector machines, ensemble methods, decision trees, neural networks. Or for classification, you might have various algorithms. And for clustering, you have k-means clustering, hierarchical clustering. Again, neural networks might be applied to clustering as well, etc. So various algorithms are there. And to help with what to choose, this is like a cheat sheet for scikit-learn. I have this slide in our repo. And if you click this link, depending on your situation, for example, it says if you have less than 50 samples, get more data. That you cannot apply machine learning with do machine learning with so few data. You need more data. Okay, if you have more than 50 samples, are you predicting a category? So is this a classification, or is it will be continuous? So if it is yes, if you have category, then we have labeled data. So it is here it is deciding if you need to use supervised learning. If yes, it will go to the supervised learning part. And if you don't have labeled data, it will go to the clustering part. So k-means clustering, etc. So this is a cheat sheet, the flowchart that you use to decide what algorithm to apply in your case. So it might be handy. And if you click on those, actually they are active links. You can go to the description of that algorithm. You see like a basic recipe. You can just copy and paste the code and see how you can apply it to your data. So today we'll be using scikit-learn. It's an easy-to-use library. You can train a model with 3 lines of code. Of course, there is so much to dig deeper. So, but this is the starting point. Starting is easy. Actually, that's why we wanted to have like a Docker instance that you can follow along. But on Windows, it didn't run very well. Sorry about that. Hopefully, in our future trainings, we can have the cloud environment so that you can follow along and get the confidence of, okay, I can do this. You can just change a few parameters and train it yourself with a little bit different setting. And scikit-learn also includes other tools for data preprocessing and model evaluation. So, of course, after you try different, you have seen in the previous slide that there was various methods, various algorithms for machine learning. You want to evaluate which model represents the data I have better. And then there is tools for that model evaluation in scikit-learn as well. One thing kind of lacking in scikit-learn is deep learning. For that, you can have TensorFlow or some other libraries. And scikit-learn is built on top of NumPy library. Let's start running our notebook. So, this is the repo I have. I just followed the steps from here. As I had told you, if you have run this at home, you must have the SciPy notebook Docker image on your computer. And then after you clone this GitHub repo, you will have the folder. And then after you cd into that repo, you can run this command, which will start the Docker container with all the dependencies that you need to do data science and Python. I'm repeating these for those who couldn't attend the previous two sessions. So now, you go to a link like this. It tells you to copy and paste this name. It might be either this or this. In some cases, you might need to replace this even localhost. And in my case, I mapped I mapped the port 8888 to 9999 because I keep the 888 for my local Jupyter server. That's why I have it there. So I just paste it here, and since I mapped it, I need to replace it. But in your case, if you just run it without port mapping, you will just run this, enter it, and then you will see something like this. Since it is mapped to this work folder, you will see like this. This work folder is mapped to a folder outside the Docker container. So when you edit the code there, if you add something into that folder, if you move a new data into that folder, it will be visible inside Docker. It will be visible inside this notebook. So currently, I have my data science workshop here. I ran the Docker image also from that folder. So for example, if I go to app folder and create a new file, touch new file, if I go inside here, you see new file is there. So that's why we do that mapping inside when I run Docker here. I mapped this target directory inside the Docker image into my current working directory. You could put any directory here, but since I was running it from my current directory, I just gave the present working directory command. So now we have the data that Kusum provided me, this housing processed CSV. I also need to import pandas library and then use pandas library, the read CSV function of pandas library. Is this large enough? Can I zoom in a little bit? Okay, I guess it's better. The example is similar to Zillow's estimate. Zillow has a price estimate for your house, for example. It is similar to that. We will be predicting house prices. When you are running these cells, you need to on Mac you need to press Shift Enter. for your computer, you can see the commands here. Run cell, run selected cells is, for in my case, on a Mac, it is Shift Enter. And you can find for your computer, you can click here and try to search for the command. So I go to any cell. This is a markdown, so it's not really a command. It's not Python code, but I can still, if I double click on it, you see the markdown code. This is how it looks normally. And when I do Shift Enter, it creates the actual how I wanted it to look. It creates the HTML behind. So, and in this exercise, you can try to apply the tasks. I try to create tasks with this task keyword so that you can try your hand on trying to do similar stuff, or you can actually explore anything you want. So this is the command to read the data. Since in my app folder, I have the data folder here, and in data folder, I have the original housing CSV and the processed version. And I can run, actually, let me insert a cell before this. Insert cell above. So I can run commands with the exclamation mark, the bash commands. And many of them actually run even without a command, without an exclamation mark. So if I do pwd and do shift enter, it shows me the current working directory as it would be seen inside the Docker image. So it is running a Linux inside that Docker image, and I am inside that directory. And this app directory, this work directory is mapped to my app directory. So if I do ls data, I can see that these two files are there. And I could add another file from here into that folder, and it would be visible there. So as Kusum already showed you, you can have the head command to just see how the data looks like. And she already edited many of the columns so that I can have an easier time to run my machine learning algorithms. But I realized that she had left this external quality also there, which would be a problem for my machine learning algorithm, because it wants, the library wants everything to be numerical or binary. So I will need to remove them. So filtering columns. So she had coded them. So for example, some columns she had used, what did you call this process of mapping this to a number?
One hot, or not.
This is not one hot,
the
yeah.
Get dummies, yes.
Get dummies is for one hot, right? This also.
Oh, right. No, it was the.
So.
This was the nominal.
Yeah, nominal. So she had done nominal mapping. The numbers, sorry, the names to numbers mapping, basically. You can go to her notebook, how she had done that. It is again in the same repo. So she had done that, but she had left the original column there. So I will need to remove such columns. And how do I find those columns? I'm also showing you some pandas, a little bit of some pandas here, a little bit more continuing what Kulsum had done, basically. Yes?
One thing I just wanted to insert, depending on what you're doing, you could also, if it's not too cumbersome, list out the columns you want to put in your model without dropping, but dropping would be an easier way depending on how long that your data frame is. As it, like in scikit-learn, if you input the data frame, you could specify the list of columns that you want to use as your input without having the whole data frame.
Yeah, I see. So, there's a parameter in scikit-learn, the machine learning training function. You can specify which columns to use.
Creating views, like creating views.
Yeah, something like it internally does that for you, basically. But what I did here, I dropped these columns. How I found them? So there's a D types inside all data frames. So here, housing is a data frame. So pandas is a library. The main thing inside pandas is data frames. So I think I don't know if they stole it from R. R also has the data frame concept. And it is basically like an Excel spreadsheet, which has like columns and rows. You can refer to each cell by the row and column. And you can do filtering like this. So for this data frame, whenever it is, the data type is equal to object, let me insert another cell here to show you what actually housing D types is first. So housing D types returns a list. So the ID column inside here, the first column is ID column, is int 64. The MS subclass is int 64, etc. But there is some object columns, which are strings. In Python, strings are also called objects. So I want to get rid of those object ones. So if I say, first let me do this. So this is, I think, you can check the type of this. So it's a series. And for series, when you do an equality, so if I want to do this operation, it returns me another series. And this series is a series of true or false. And so you can use such a false and true valued series to filter another series. So the result of this equation operation is a series with true and false values. And if I put it inside the series followed by a square bracket, it will filter this series with the ones that has true as the for this Boolean expression. And let me check how many such rows are there. There is 16 rows. So for a series, you can put a dot shape, and it will tell you the shape of it. So it's a one-dimensional. That's why there's no second dimension. This is a one-dimensional series, so there's 16 rows in it. Let me check if sales price, I remember that the column was sales price, if I remember it correctly. I'm checking it like this. Yes, sales price is in housing.columns. So housing data frame has, as you had seen again in Kulsum's presentation, has a columns feature which lists all the columns. And this is a Python keyword to check if this is inside this value. Again, actually, we can do this too to see the type of it. So it is a housing.columns is a pandas class basically, but it supports the in keyword. So let's see how we can remove these undesired columns. In my case, Kusum had left some of these columns that I don't want to be there. So originally, there is 238 columns. So len is a Python function, and it tells you the number of elements inside this parameter. And I will move again, using a Boolean series here. Instead of all the data types, I want to get data types that are not an object, and I'm choosing all the rows. So the log function, so it's not a function because it is square brackets, so I think it's a function. It's not, I guess, important, but this takes as a first parameter the rows. So I could, for example, give it 1, and it will be only the first row. If I said 1 to 10, it would be or 0 to 10, it would include the first 10 rows. But if you do as colon alone, it gives you all the rows inside this data frame. And the second parameter is how will I filter the columns. And now if after I run this, I have a new data frame. So the original housing didn't change. It got filtered and it got assigned to housing ML. Like you said, it creates some kind of a view, basically. And now, if I check the length of this number of columns here, I have 222. So 16 columns that were object, that were string, got removed. Now we are at the step where we will be doing the machine learning. So we want to separate the target into a new variable. What was our target's name? Sale price. We want to predict the sale price. And currently it is a column among other features. So it doesn't know that it is the target. And scikit-learn needs two variables. The first variable is the features variable, and the second one needs to be target variable. Usually they are named capital X and lowercase y. And the target needs to be a 1D array. Here comes the NumPy part. As I mentioned, scikit-learn is built on top of NumPy, and it needs to use NumPy objects instead of data frame. So the X and Y data type needs to be NumPy's ND arrays, n-dimensional arrays. Housing ML shape gives me how many rows and how many columns my new data frame has. And I will split data as features and target and take the sales price value into its own 1D array. So if I run this, this pop function removes this sales price column in place from this data frame and puts it into this 1D array, one-dimensional data frame, actually, I think. Actually, sorry, it's a series. So the type of sale price becomes a series since it's one-dimensional. And now, as you can see, one column is removed from housing ML. So it is, instead of 222, it is 221 columns. And the but as I said, scikit-learn needs to work on ND, what was it called? ND arrays. So I convert this sale price series into an ND array using the values feature. So now Y is ND array, and it's a one-dimensional array. The first value is the number of elements inside it, and there is no second dimension. So we also need to get the X into the X variable into ND arrays. Again, we will use dot values. And the shape of X is same as the data frames. So we can check if the first value inside those shapes match. So as you see that there is 1,460 rows in both of these data structures. So the first model, what would you do if you had no features about these houses? You only had a sales price. You wanted to predict a new house's price. You would just take the mean, right, of all those houses. So that would be the logical thing. Of course, we should do better than that, but that could be a baseline for us to evaluate our future machine learning models. So that's why it is called a dummy estimator. We will import this dummy regressor from this scikit-learn dummy library. This is the 3 lines that I mentioned in the slide. This is the 3 lines needed to train a machine learning in scikit-learn. It's that easy. So, but of course you need to know which one to do, which one to use. So in here we want to assign as mean to the strategy to create our dummy regressor, and I named it mean regressor. And then when I say mean regressor fit, it will, even though it won't really use any of these values inside X, I still put it there. It will actually, the training in this algorithm will only use the Y values. It won't use the features. It will just take a mean of all the values, all the sales prices. It's a dummy predictor. But I still feed the X because all of the estimators in scikit-learn follow this API. You call the fit function on them. You give the features and you give the target. For example, if you go to Google and search for decision tree, random forests, for example, scikit-learn. So random forest classifier, you will see that it will have a fit function as well. Yeah, in the example, you see that again, it's the same thing. You just import the random forest classifier, you process your data, that you get your X and Y, and based on those X and Y, you fit the random forest classifier. And then later, when you want to predict, you use the object. Now it has the model inside it. After you run the fit, it creates the model. It has the model inside it. Now you can call the predict function. That's it. So let's see. Now we finished this. The mean regressor, the dummy regressor is trained. And when I predict for all our rows, when I do the prediction, it returns me an array with all the predictions for all those houses. And this is the prediction, $180,921 is the predicted value, which is mean of all the values in that city. So this didn't use any of the features, basically. It just took the mean. There are many ways to evaluate your models. One of the functions you have is the score function. So when I call the mean regressor.score, again giving it the same data set, it will calculate me, it will give me the calculation of the score for this model, which is 0, because it is, by definition, the base model where we measure us against. So mean regressor is the base for us. We want to improve on that. And since this model is the mean regressor, its score is 0. It can go up to 1. So now I will show you something that will make more sense. We will fit a linear model. And before that, let me show you some slides, I guess. Kusum already had done this. So there was columns like this. They are mapped to individual columns. So each possible value inside this column became a column. So lot config inside became a column. And if the first row had value, so in this data set, for example, the first row was lot config was inside, and then the second row had the lot config value was FR2, and it encoded like that because in scikit-learn we need to have numeric values. So linear regression as you know, will fit a model like this. So the y equals a plus bx. Y is the target variable that we want to predict. X is the features. In this case, it's just a single feature, but you can have multiple features. And A and B are the model parameters. So when we say fit, it will find the best A and B values. So as you remember from your linear algebra class, maybe, so a line is defined by where it intercepts the y and what its slope is. So b is the slope and a is the intercept, as you remember. So it finds the best line that fits. For example, I guess we will see an example. So let's move ahead. So here, again, I'm just importing linear regression and creating an object with the default parameters. Again, if you go to the documentation, or if you, I guess, do this, you see, you can see the documentation by adding why does it? By adding a question mark, and then if you put Shift Enter, it shows you the documentation also. So linear regression, you can give fit intercept equals true or false, normalized. So these are the default values. So by passing no parameter, I pass them actually these defaults basically. And then it tells you what you could choose. You could choose, for example, normalize equals true. Then it will normalize the values that are in the features. So now let me close this window and Shift Enter. So now I have my object which can do linear regression. And then I am taking, in this case, first I want to try with only one feature. Let's see how correlated the house value is to lot frontage. I fit a linear model to this variable. So only one column from the input data, and I fit it. And you can see that actually it used these default values since I had not passed any values when I created the object. And now I can do prediction. I can again use the same load frontage, and I use the linear model.predict, and these will be the predicted values. And if I do a score on this, linear model.score, and again use my column that I used to predict the y value, and original real house sales values. And this is a little bit better than having nothing. It was 0 when we just estimated the mean. It is now 0.11. Of course, I don't think lot frontage is a very good estimator for the house price, right? But we can still see there is some correlation. So we can import matplotlib, as Kusum had done in the previous session as well, and do a scatter plot. So this is the lot frontage, and this is the house value. You can see that there is some correlation. And here I will do the scatter plot, and also I will do the x values, the features, and the predicted values. Since the prediction is basically a linear model, when I plot them, it will be a line. So this is the model that we train. So when we say, okay, the house's lot frontage is 200, now it will predict that the house value is $350,000. That's what this machine learning model came up with. So I was giving you tasks. Maybe you can do it at home. You can look at this tutorial and add labels, meaningful labels to those charts. And you can try at home maybe replacing those scatter with plot and see what happens. Can you really replace it with plot or not? So effect of using a better predictor. So ground leaving area should be a better predictor than lot frontage. Actually, she had already shown that. It was the second best predictor. I think the first predictor was already the overall condition, which is, I think, the real estate agents maybe were thinking about the value of the house already. That's why it's the best predictor. So now, instead of X lot frontage, I have X area. I'm taking only this column into my training and fit a model on that. And now we have another linear model. I think this was the lot frontage. And then you can look at how I did. When you are doing data science, you really use a lot of, all programmers, all of us do lots of Googling, lots of copying and pasting from codes. But in data science, for example, drawing these charts might not be easy. And for starters, it's easy to look up examples and change some values or parameters, etc. It looks more complicated than it is. So as you can see, blue is a better predictor, and we will see this. We can see the score as well. Again, I scored it, and now it's even better than the lot frontage. So instead of 0.11, we have 0.5. Now I will do the same using all predictors instead of choosing a single column. So you remember that we had 221 columns. We will do a linear model fit using all of them. And this will be our third linear model. When we do the linear model that predict X. So I saved it into the same linear model. So if in the first session, I had mentioned that it might be confusing sometimes because in Jupyter notebooks, you can do out-of-order execution. So now, in this linear model, I have my third linear model. If I go above and execute this line again, I will have an error. Because I guess I didn't train it yet, so it couldn't score. So it shouldn't, let it not confuse you. So now we have this fit. Now this linear model has the linear model inside it, which is trained by all the columns inside X. And when I do the score, you can see that it is now 0.91. It is pretty close to 1. And if I plot that, you can see that the correlation is visually, you can see that the correlation is very high. One thing I want to mention before wrapping this up, I didn't have the time to fix it, but a caveat I want to give you. When you are evaluating your models, you actually should not be giving all your data in the training. So what we usually do, we split the data into maybe 1/3 or 1/5. So we save some part of it for evaluation so that we make sure the machine learning model is not memorizing, basically. It is generalizing. It can, when it sees a totally new example, it can really predict some value. So that is something that I did wrongly here. In the next step, I will do that. So what you do, there is again functions to easily do that in scikit-learn. There is, what do you remember the name? Split? Yeah, train test split. So there's a train test split function. You can assign those original input values into two separate sets, train and test. And then you do the training only on the training set. And then you do the scoring only with the test set. So that's an important distinction, because there's something called overfitting. That's an important term. That's one of the, so overfitting and underfitting, these are terminologies in data science. So if you, for example, have few data sets and your machine learning model is very complex, instead of, like, for example, putting a linear fit, it could maybe fit something like directly passing through these curves. But actually, in the real life, it is more like a linear fit. And then in that case, actually, it will have more errors when it sees new examples. But if your training set is the same as your testing set, since it won't be seeing those new cases, you won't be realizing the overfitting. That's why it's important.
Is that relevant in just a real simple model like this one? Is it possible to memorize?
I guess for linear model, it wouldn't matter that much, since it's not very complex anyway, and we have enough data. So where it really matters is, for example, in neural networks. The mathematics of neural networks is very complex. You have many nodes feed to each other, and then there's backpropagation, etc. It can create really complex models. And the models itself are like gigabytes sometimes. You have gigabytes of data input to the neural network, and then the output is also like megabytes or gigabytes. So since the model is very complex, it is overfitting to your data. It is basically memorizing what you gave to it. So that's very important when you're evaluating different models that you train, to have your test data and training data separate. Let me see if I had something else in the slides. So the algorithmic intuition behind is it fits the line that minimizes the residual errors. So for example, if this is your training data, it's fitting a line that minimizes the total of these errors. That's what the fit function does. And then it gives you the A and B corresponding to this line. It says A and B is inside the trained model. Okay. And maybe some resources. If you are really want to go into data science, maybe you might want to follow these, or O'Reilly's data science, data newsletter, artificial intelligence newsletter. There is newsletter from KD Nuggets. And there's a good blog towards datascience.com. We can check these out. And there is competitions in data science, Kaggle datasets and data.world and data.gov for government's open data. Yeah, Kaggle. And let me remind you again, we have this Data Science Pros meetup. You can start following it. Hopefully we will have new trainings posted there. And again, we have a we have a coupon code for a $50 discount from Data Science Connect Tech, where we will be doing a full day workshop, an extended workshop of this one. We will go into a few more different machine learning models, like at least random forests and decision trees, etc. And Kusun will be especially doing much more extended version of her talk from today. Thank you all for attending. Any questions?
Go back to Docker for Windows at $10 thing.
Oh, okay.
It's free.
Yes, PactPub. So P-A-C.
You have 2 hours.
Yeah.
Better get it now.
P-A-C-K-T, Pact, PactPub.com. You can Google PactPub free learning. So every day they have a free book. I usually go there every day and get the free book they offer for that day. Any other questions?
There are these need to see if the data is normally distributed.
Statistical analysis, right? So again, Kusun will be covering, I think, this statistical package from scikit-learn. What was it called?
One is called stats models. It's a separate Python library. I believe scikit-learn has some.
Yeah, I'm not familiar with all others, but
NumPy, NumPy does.
thank you very much for attending. Have a good day.